Now we're going to start looking at log graphs, and before we start plotting the graphs or filling in the table, we're going to revise some of the log rules. The first rule to remember is log to the base b of 1 is equal to 0. So it doesn't matter what the base, log of 1 is 0. So in this case we can put the 0 in on that table. The other one, that's really useful, is log to the base b of b is equal to 1. So as we got log to the base 2 here, log to the base 2 of 2 is equal to 1, so we can put a 1 there. The final rule to remember, and we can really use this, is log of x to the n is the same as n log x. So if we can write these all as powers of 2, then we can find our values. So if we look at 1/8, 1/8 is the same as 1 over 2 cubed, which is the same as 2 to the negative 3. So log of to the base 2 of 1/8 is the same as log to the base 2 of 2 to the negative 3, which is negative 3 log to the base 2 of 2. Now we know log to the base 2 of 2 is 1, so that makes negative 3. So we can put that there. Similarly, 1/4 is the same as 1 over 2 squared, which is 2 to the negative 2. So log to the base 2 of 2 to the negative 2 is going to be negative 2. A half is 2 to the negative 1, so if we take the log of that, it's negative 1. Similarly, 4 is 2 squared, so log to the base 2 of 2 squared is 2, and 8 is 2 cubed, so this is going to be 3. So when we come to plot this graph, the first thing we know is that log of x is 1. So when x is 1, this is going to be 0, y is going to be 0. We also know log to the base 2 of 2 is 1, so when x is 2, y is 1, so there's a point there. Now we go to the next power of 2, which is 4. Now log to the base 2 of 4, which is 2 squared, is 2. Next power of 2 is 2 to the 3, which is 8, so when x is 8, the log graph is 3, because 8 is 2 cubed. And similarly going this way, when it's negative 1, or half, it's negative 1, negative 2, negative 3 for an eighth, and then we can draw the graph in like that. So the key points to notice is it always crosses the x-axis at 1, so the x-intercept is 1, 0. There is no y-intercept, and in fact the y-axis is the asymptote. So the asymptote is x equals 0, which is the y-axis. Your domain, now looking at this graph, what values can x not be? You see, if y is the asymptote, the y-axis is the asymptote, it can get very, very close to 0, but can't quite touch it. And you can't have any negative numbers. So the domain is going to be x is such that 0 is less than x or x is greater than 0, where x is a member of the set of real numbers. Now looking at the range, y is such that, now looking at the range, there's no value that y can't be, because it goes down to the negatives, goes up to the positives. So y is just a member of the set of real numbers. The other log rule to remember is that if log to the base b of x is y, then we can rewrite it as x is equal to b to the y. The base of the log becomes the base of the indice. And looking at this, we can see, to plot the log graphs, if we can put 2 to the x, y equals 2 to the x in your calculator, and then go to the table forms, you just need to swap the x and the y values over when you're plotting it. Because the log graph is basically the exponential graph, where this is your graph y equals 2 to the x, reflected in the line y equals x. So if we take that exponential graph and reflect it, we're going to get our log graph. And where this crosses at 1 on the y-axis, this is going to cross at 1 on the x-axis. So the cheats way is to use your calculator, put it in index form, and then just swap the x and the y values over when you're plotting it. Now we're going to look at some of the log transformations. The first one I want to look at is log 2 of x plus 4. Now, because the plus 4 isn't in the bracket with the x, it's standalone, this is a vertical translation. And what that means is, instead of y being 0 when x is 1, y is now 4 when x is 1. When x is 2, because it's a log base 2 graph, y would normally be 1, y is now 5. Similarly, when x is 4, y would normally be 2, and it's now 6. So we can draw the graph in, and you can see it's the same graph, it's just moved up by 4. No effect on the asymptote, just the graph is moved up by 4. The next graph I want to look at is this one. Now you can see here that the plus 4 is now in the brackets with the x. So this is our horizontal translation, and because it's x plus 4 all in brackets, it means it's moving left by 4. First thing I like to do is see whether it has an effect on the asymptote, and in this case it does, because the asymptote would normally be x equals 0, and it's now going to be x equals negative 4. Now, a normal log graph, when it's a distance of 1 away from the asymptote, it would go through the x-axis. So the same is going to happen here, so it's going to cross the x-axis at negative 3. Because it's log to the base 2, when it's 2 away from the asymptote, which is x equals negative 2, the y value would be 1. When it's 4 away from the asymptote, because 4 is 2 squared, the y value would be 2. And then 8 away from the asymptote, the y value would be 3. And then you can plot the log graph. So it's the same log graph, it's just shifted left by 4, and you do the same distance from the asymptotes for the points. Now if we combine the two transformations together, in this one we got a log of x plus 3. Now because the plus 3 is in brackets with the x, that's your horizontal transformation, and because it's plus 3 it moves left by 3. So the new asymptote is going to be at x equals negative 3. And then we've got this minus 3, which means everything moves down by 3. So normally, when you're a distance of 1 away from the asymptote, the y value would be 0. But now, because of the vertical translation, the y value is now going to be negative 3. When you're a distance away of 2 away from the asymptote, it would normally be 1, but 1 minus 3 is negative 2. a distance of 4 away from the asymptote when x equals 0 would normally be 2, y equals 2, but 2 minus 3 is negative 1, so it's now going to be negative 1. And then a distance of 8 away from the asymptote would normally be 3, because we're moving down by 3 it's going to be 0. So the new graph's going to look a little like that, only it should go through the points. Next we want to look at this y equals 3 log 2x. Now if you remember from our graph transformations, a 3 in front of the function is a vertical stretch. So we're going to multiply everything by 3 to find the y value. So the asymptote doesn't change, that's still x equals 0. Now when x is 1, y would normally be 0, and 3 times 0 is 0. So that's not going to change, it's still going to cross the x-axis at 1, 0. When x is 2, y would normally be 1, but now it's going to be 3 times 1. And when x is 4, y would normally be 2, and now it's going to be 3 times 2, so it's going to be up at 6. So our new graph is going to look like that, a lot steeper. But the asymptote stays the same and the x-intercept stays the same. Next two transformations we're going to look at. The first of them is log to the base 2 of half x. Now if you remember when we did the transformations of graph, f of ax was a horizontal stretch with a scale factor of 1 over a. Now because our a is a half, it's going to be a horizontal stretch with a scale factor of 2. So what that means is normally when x equals 1 it would cross the x-axis because y would be 0, but now it's going to be 2 times 1, so we're now going to cross the x-axis at 2. And normally when x equals 2, y would be 1, but we have to double that because the scale factor is 2. So now when x equals 4, y is 1. Similarly, normally when x equals 4, y equals 2, but we need to double that, so when x equals 8, y equals 2. So all the x values are doubled. Again, if we go back to our transformations for this graph, y equals negative f of x was a reflection in the x-axis. So this is going to be the same. Our normal graph would look like this. So our new graph is going to look like that. Still crossing at the point 1, 0, and the asymptote doesn't change. Final transformation I want to look at today is log to the base 2 of negative x. And if you go back to our transformations before, f of negative x was a reflection in the y-axis. And this is no exception. So our normal graph would look like this, but because it's log to the base 2 of negative x, it's going to look like that. And instead of going through 1 on the x-axis, it's going to go through negative 1.